roll through a little installation application on this boiler today. So primarily what I want to cover, just looking at it, is there's just some of the field wiring to the unit, specifically the incoming power. Just be very specific about what you need, what your requirements are there. As well as when we look at this little unit, small, but there's a lot of little added on functions to this little boiler. So whether it's some extra components or some little extra functions, the user interface, all very user friendly. And really, when we look at a lot of stuff added onto it, you don't have to add or pay extra at the wholesale to add those other components. So I find the extra components really help in, after the boiler's installed, you have to do a little bit of troubleshooting and stuff like that. There's a lot of good stuff on there. We're going to review all that stuff and then have a look at a few just simple drawings and some applications for the Vitotron. So when you have one on site, you're considering one, just some different methods of piping it, wiring it, that sort of thing, and things to think about as we're rolling along there on that side. So we're kind of roll through those three things as our main objective. First, I want to tell you a little bit about what the boiler, what the units we have as far as an offering. So, the sizes, the capacities, and, functions, requirements. We have 5 different sizes of this. The model number is a V as in Victor, L as in Larry, N as in neutral, 2-4 is one of them, 2-6, -8, -12, and 14. So those are the kilowatt inputs. And just below that, you'll see the BTU capacities. We roll up to about just under 49,500 BTUs on the largest unit, the 14 kilowatt boiler there. And these are staged units as well. So we'll have a look at how many elements are in these units. And they're not just full on at that output. We can stage those elements as we move through here. So they are a bit of a reset boiler there as far as turn down goes, as well, being electric boiler. Voltage at 240 volts, that's your incoming power for the elements itself. We'll have a look at that. There's also, just to mention, a 120 volt requirement, incoming power to operate the pump output. So there's 2 different power sources required. One for the heating of the heat exchanger. The other one is for the pump operation. Your rated current as far as your amp draws, so your circuit breakers, you can see we go from about 30 amp breaker on the 4 kilowatt up to 80 amp breaker on the 14 kilowatt boiler, with a split there on the 12 between 60 and 70 amp breaker. 3 elements, all of them have 3 elements in these units. And of course, the pump output, 120 volt single phase with a 15 amp circuit breaker recommended for there. So on the right hand side, you'll see that incoming power. We got the line in the neutral and the ground, a little disconnect there on the bottom. That's actually on our unit in our lab here in Langley, British Columbia. On the water side of the system there, we see maximum temperature. So we call it a low temperature boiler that limits at 140 as far as an operating temperature. That covers a vast amount of our hydronic applications these days, especially, typically sizing now for condensing applications and boilers. A lot of designers have gotten kind of used to those low temperature designs. A lot of your retrofit applications, if you're going from a gas boiler to a, kind of chatting about that before we started about a lot of municipalities are banning, putting in fossil fuel equipment, and they want you to go to something electric. This is an option for you to go there. And of course, a lot of those systems that we're replacing, low temperature, just kind of keep that in mind that we're up to about 140 Fahrenheit, 60 C as our maximum supply temperature for the operating side of it. It does have a manual reset limit. They're kind of interesting how the limits are wired on these. They are a low voltage operation to essentially disable the elements. We'll show you how that works in a little bit. But at 194 Fahrenheit, we're going to trip that manual reset. And it's just a little mechanical limit there you can push to reset. The connections are 3/4 inch on the bottom. We'll have a little quick review of that. And it does actually come with its own built-in expansion tank. So one of those extra components that we will not have to look at as far as purchasing from the wholesaler. However, it's a 1.6 gallon, again, low temperature, even with, a radiant system, your expansion rates could be very limited with the temperature rise that we're talking about. But if you do want to add an expansion tank in the system, I think a couple of my drawings will kind of show some recommended locations. Should you need to add one, we'll kind of point that out. But reality is that you can't really oversize your expansion tanks. You would just add more cost to your system. But it does have one already included in there. And like I say, for 95% of the applications, that's going to be more than enough for you. It comes with a 30 PSI relief valve. Just kind of jumped the gun there a bit. Sorry about that. There is a minimum operating pressure. It does have a pressure sensor in it. We'll have a look at that at 7 PSI. And a pretty small boiler, like I said, 28 by 18 and by 9 and 7/8 deep. So it fits in a very small spot. And that's, real estate being what it is nowadays, having that small footprint is very advantageous. And of course, the minimum flow rate of 1.32 gallons a minute. We do have a flow sensor in here picking up that flow rate, and we'll review some of the things that the boiler will do when it has a lack of flow to kind of give you some indication as we move through here. As I mentioned, we do have some connections here, a supply and return on the bottom, return on the right. Just like on a Vitotron's boiler, if you're a Viessmann contractor and you've installed 100s and 200s, as far as Vitotron, same kind of idea. We return on the left-hand side. We supply out on the right-hand side. This is the exact same concept. These are a G thread, British Standard pipe parallel thread on these. So they're a gasketed connection here. We do have line sets that are available and adapters to go from 3/4 inch to NPT, as well as these 15-inch line sets that are available here as well. We've actually had recommendations. A lot of guys will actually use copper female adapters or copper male adapters, just NPT. As long as you use the gasket, that's acceptable as well. We tend to say avoid using black iron fittings just because of there's no flatness to that thread, and you might cut into those little gaskets there. So NPT, copper, some of your PEX adapters stuff, all that have been, we've used NPT directly to the G thread here. However, if you want to use an actual G thread connection, we do have some of these adapters that you can add on or order to make that transition between the G and the NPT here. Just a note, like I say, we've done it a few different ways here. An NPT to that O-ring is acceptable if you keep it within the copper and some of the PEX and some of the different style fittings that are out there. As far as small boiler, there you go. There's your footprints and some of the distances as far as clearances. In the manual, we show this, but a very small footprint. A lot of boilers that we work with, especially here in the lower mainland of BC, you're using like crawl spaces or underneath a set of stairs, that sort of thing, as far as your mechanical room. These are great, actually, even to store right beside your manifolds for your heating system. So we've had in some applications where it might, the boiler might not be big enough for the whole building, but they're actually installing these per floor where the manifold locations are. So they have that connection there, and essentially just running that 240 volt and 120 volt connections to those different areas. And now you've got essentially heating on every floor of your building with a different boiler based on your capacity and requirements. So they do fit into some pretty small spaces, and so good to fit as far as that goes. As far as your connections on these units to access, so they do have some screws that hold the cabinet in, but a nice, neat little cabinet that has a hinge on it. So you don't completely remove the cabinet when you're doing any service or any troubleshooting, that sort of thing. You take the screws out on the top, and then there's some screws on the bottom here. We remove those, and now you can just open that hinge door and have full view. You'll see a picture here in a little bit of what the inside of the unit looks like as we roll through. But I just wanted to emphasize here in this, kind of going back to this one of the first slides that we looked at, on the top, the red, I believe that's a crimson red, if I'm not mistaken, is detailing or outlining the 240 volt single phase requirement up in the top right there of your incoming power. And this is the 240 volt that's going to essentially be used by the elements to actually provide the space heating. On the bottom, we have a purple, maybe a plum purple. That one there is a 120 volt connection, and that's separate. So the 240 volt is for the powering of the elements to heat the boiler. You also need a separate 120 volt entrance to come into that for the pump outputs that are available on the boiler itself. So just wanted to kind of review that, two separate powers. This is what it would look like essentially as a quick review here. A is your incoming power 120 volt that would come in to terminate on the top here, and that's going to operate your pumps. So we'll have a look at that in a little bit, how that all looks in a bit more of a detail. But just to show you separately here that there does require two power sources. So there's the 120 volt. And then on the contactor side here, we've got our L1, L2. That's our 240 volt coming in. And that's going to come over and it's going to go through some contactors. And then on the actual operational side here, we got a step down transformer. And your limits are actually wired through a 24 volt circuit here, and they provide either power for the operating limit here for the triacs to operate your elements here to start and stop those. So if the operating limit opens, it kills power to this board where the triacs sit, and of course your elements are not going to get powered up there. If the fixed high limit opens up here, it's going to actually open up, and it's going to open up the contactor power here so that we lose the 240 volt directly into the triac board itself. So there's your safeties sitting on that side. But just to kind of mention that there are two different power sources from A and B here. Electricians run an extra neutral with that 240 volt. They could possibly split that with a neutral and go to, give you a 120 volt and a neutral off of that 240 here. You'd have to talk to your electricians about how all that would work. And of course you have to make sure you have separate circuit breakers for those as well, or fuse protection. So just a little bit more detail. There is our contactors A and B that we just saw on the previous slide, and they're going to go through our fixed high limit. So the power to that contactor goes through the fixed high limit. As long as that fixed high limit's closed, those contactors are engaged, and they're powering up our main board here. And of course, through the triacs, we can stage these different elements 1, 2, and 3 here to turn on and stage that should we need, a low load day. We don't need all 3 contactors. It's going to stage those contactors to save you a little bit of energy and power. And on the 120 volt side here, just again to review, there's the little bit up close and personal look at that connection on 120 to the neutral line in our ground. And then we got our pump outputs here on the bottom. Now, there's actually 2 pump outputs. The main pump output for the built-in circulator on the boiler is already pre-wired in the factory. It's a little Welo Star S21. So if you're familiar with the Welo brand, it's a very similar to a lot of the as far as outputs, the Grundfos, the UPS 1558s, some of your Takeo kind of 007, 010 type of pump. So residential style of pump. And you also have another pump output here that's available, pump 2, for should you require a second pump output for, say, primary, secondary, or whatever you might look at. As far as operation of this, there is a fuse protection on that little board, but the power goes through a little contactor here. There's actually a little pump relay built into the unit here. And if we were to look at that, the main power comes in. K1, K2 is a pump relay. It closes, of course, that power goes through parallel through the 2 amp fuses. So pump 1 and pump 2 have their power output coming from actually this little relay contactor first, allowing the power to go through to those contacts on the bottom. So we power through here. If you follow that little L, it goes from K2 up around. It has to close here first, up through K1, and then we power up through our fuses here to operate those little circulators. So a little conceptual drawing here on the left-hand side of what that might look like. So you get your built-in pump, kind of shown in the boiler here, and then a secondary pump, which we could use on pump 2. So we have a primary secondary system, and this is what we're kind of looking like. All right. So some pretty good little added functions on a small boiler with an extra relay output there. You don't have to buy another pump box for that, should you want to do a primary, secondary. And As far as the residual heads, we do have disposable or available pump head available here. So that built-in pump on speed 3 here, or 2 or 1. You can have a look at what your settings are. I believe it's preset at 3. You can make the adjustments should you want. And your flow rates there, obviously, we're down below 5 gallons a minute here at some pretty low pump heads. So you really want to make sure you do your math on whether or not you want that primary, secondary. And even though it's electric boiler, it does stage. And a lot of times, just like a condensing boiler, probably be beneficial to pipe these closely spaced tees or primary, secondary, depending on your applications. But again, you've got a pump in here. It is going to have some limitations as far as what's left over, what that pump can do. So if you're really zoning heavily in your systems, for instance, that's a consideration. If you're not doing a lot of zoning in your system and you're just kind of minimizing that side of it, that tends to be a little less cycling of the boiler, that sort of thing. But you're still looking at that high pressure drop. So whatever we're dealing with there, just make sure you're fitting your system within the capabilities of this little pump. It also does have a little drain or purge side of it. So the center of the pump there is a little screw. You can back that off. So when we're doing startup, oftentimes we're going to want to purge that to make sure we prime that little pump. We can back that little screw off in the middle and make sure you have a little rag there, just kind of catching the water underneath, and just let that make sure you get the air out of that impeller before you start that up. That way there you're not cavitating that pump and causing any issues where we could burn that little pump out. So those little slots in there are made to make sure that we open those up and do that bleeding on startup with these little boilers. And there's the kind of, I promise you'd see it, what this looks like inside. Lots of little things built into this unit. On the right-hand side, your heat exchanger, it's all insulated. You got an air vent up at the top there we'll look at. But just kind of rolling through a few of the little accessories that we do have here. We talked a little bit about the resets and automatic reset and manual resets and stuff like that. But there's your pump location. We've got a few other little pieces here I want to talk about just quickly. So we already chatted about this. It's all 24 volt really on the safety side of it versus whether it's the auto reset here or the manual reset that we're looking at. So both of these, as I mentioned, there's our little manual reset button there. So 194, that's going to pop. And this guy here, automatic reset, is going to be opening up at about 140 Fahrenheit. So 140 to 194 is kind of those limits. And we also have a bunch of some sensors that are already programmed to this as well. So if you want to do like delta T functions and all that kind of fun stuff, this boiler has all of that information for you to kind of read out through a very easy little display. Now, so T in is temperature in. That's our return temperature back to the boiler. And we've got a sensor essentially connected right to this little copper element that's sitting on the little track board. And I'll show you what that means in a minute. So the return water goes back through and we make contact with this little circuit board. The idea behind that is that as that return water comes in, this little board here is going to get heat up with that 240 volts and operating off the resistors. This is actually going to pick up a little bit of heat from that, cool that board down, and just keep that board essentially acting like a little heat sink for that little track board, just to keep it essentially functioning longer in your system, right? They wear as get heating up and that sort of thing. So very nice little added little thing here to use that water here essentially to cool that system down. And we've got a little sensor to pick up what that return temperature is. The relief valve is already pre-piped for you. It is a relief valve. As you notice, it's on a horizontal plane here. Not all relief valves can be mounted like this, and you should check with, should you be replacing a relief valve here, you should just check to verify that is able to be mounted in this configuration. Some manufacturers, the relief valves are only meant to be positioned in the vertical position. So the little tag here in the back that we see will detail what type of position this thing could be installed in. And this one here is allowed to be installed in that horizontal position. So it's already pre-installed for you. No need for you to pipe that during your installation. There's an air vent at the very top of our heat exchanger here with the built-in elements here. And of course, that is right at the top to easy to get the air out of our heat exchanger. It does have a little PVC pipe. You see a little bit of tubing connected here. The idea is that that goes down and it actually hangs off the bottom here so that we're not, any water coming off this is not going to drip down on the machine. So we make sure that that's connected here. And we could take that down to, down the bottom here, and it kind of sits there. And if should we have anything issues, it'll just drip out here versus interior of the unit here itself. On top of that, as I mentioned, we have a little pancake style of expansion tank that's sitting in the back. We got a little Schrader valve there that you can access for service should you need to, but it sits at the back of the unit here. Reliable little expansion tank. We've had, like I say, these installed now for a number of years. We haven't had any issues really with these expansion tanks. They are 1.6 gallons. They're set for 14 psi. Remember, your minimum pressure is about 7 psi. So we want to get that pressure usually about system pressure typically is usually 3 psi higher than your expansion tank pressure, just to put a little bit of a water seal on that expansion tank. So, your typical pressures here with that set at 14 would be somewhere around 17 psi. So well above the requirements of the minimum 7 psi that we have in the pressure sensor. And of course, we've also added in a little pressure differential pressure bypass valve as well. So something that we use a lot when we're talking about unloading pump head. If you don't not using a variable speed pump, and of course this is a 3-speed pump we have built into this little unit. And during your commissioning of your system, of course, you're going to set this to make sure that we meet the flow rate that we're looking for. So it's built in. Again, you don't have to buy this. It's already part of the system. It just kind of sits at the bottom portion with a little red cap on it there at the bottom of the little electric boiler. And you've got your different pressure ranges here from 1 to 5. And we're just going to set this up. Essentially, we're going to make sure that all the zones are open and make sure that you've got full flow. So we're essentially all the zones, meaning that even the one with the highest pressure drop is open and we got flow. And we're just going to start to close this valve off until we start getting a little bit of a bypass flow going back through the unit here. So we're essentially setting up where once the zones start to close, this little spring will start to open up a little bit further and we'll have a little bit more bypass flow. So the whole idea, you have to set this at the tipping point, and from that point there, the valve will operate automatically based on when you have 5 zones and only 3 of them are opening. This valve will open up to a specific pressure to make sure we unload that pump head. So we're not going to have any issues with the getting that pump into areas where it's inefficient or we're causing some problems as far as deadheading, etc. On this unit. So good for, like I say, if you're doing a direct connection of your heating system to the unit itself, you don't have primary, secondary, you can adjust this so you have good flow through your whole system, and this is operating correctly. All right, so just some exact same stuff I just talked about, how we set that up. And also built in, we've got a little magnetic a dirt filter as well. So we got a strainer and a magnetized here. So that's going to pick up any debris and any dirt in your system coming back. Always advised to have these in your systems, especially if you don't know what you've got cooking inside of that system, as far as the everything from hard water, soft water, pH levels, etc. Additives that you're adding into your systems. Always good to have some strainer there. That's going to essentially save things like the pumps, the debris attaching to the elements inside of the heat exchanger there when they're hot. That stuff is what scales up and then starts to essentially shorten the life of your electric boilers. So again, having the strainer in there is very helpful to make sure that we avoid a lot of that stuff. But again, it's a maintenance thing. So once we install this, you start dealing with high pressure drops and issues with pump flow. A good spot to start looking at is let's open up this little cap and have a look at just how much debris is stuck inside of that little strainer. So just keep that in mind that it's built in, and that will be a service thing to look at in the future. We had talked about the temperature in, the return temperature already. Now we have the temperature supply out. So we have 2 things here. This one little device feeds back through a little ribbon cable there, both flow. So it gives us a flow rate in gallons a minute. and it also senses the supply temperature going out. So we know flow, we know temperature in, temperature out. It's very easy to kind of calculate things like BTUs, et cetera. And this boiler actually will calculate your current BTU output as the boiler's in operation. And you can go through the little service menu as we'll look at here in a little bit. But like I say, all this stuff is in there great because you can use it for troubleshooting and stuff after the boiler's been installed to see if you got any problems on that side of it, on the hydronic side specifically. All right, a little pressure sensor, as I mentioned. You can turn this off if should you want. It's in the kind of advanced programming of the interface, but it is set for 7 psi, and you'll get essentially a fault there if we're down below that 7 pounds of pressure. So the pressure sensor is connected directly to the system at the bottom there. And some of the things you might want to use an electric boiler for, obviously it's connected to your utility, so directly your power contact here. What you could do if you have, I know back east when I used to live back there years ago, we used to have this time of use function where during the evenings it was cheaper electrical rates certain times and then certain times during the day they would have slightly cheaper electrical rates. But if you're on that time of use program, if you use power, electricity in the peak period, you'd actually get charged a little bit more. So this little jumper called OP is for off-peak operation, and essentially, if you're on that type of a program and you want to make sure the boiler will not operate during those peak periods, you could essentially have a timer or whatever connected to the OP terminal. So it opens during the time of day that you don't want to use the boiler for electricity and cost a little bit more. And of course, it closes during the times that you are essentially you'd be able to use the cheaper power based on that program. So what it'll do is even if your thermostat closes and you got to call for heat here, if that contact is open, it will essentially disable the boiler. It will give you an indication on the boiler that it's not firing as a result of that. There's some diagnostics in here, but just so you know, it's available in there. Very simple contact for you to use should that be desirable. Of course, your TT contact here is a dry contact, potential free. We don't want any voltage on these contacts. That or the OP terminal here should be dry as well. And then off to the right-hand side, on that same terminal strip, we have the outdoor air temperature sensor, or T external temperature sensor external there, just a 10K NTC, which is the same as all of our current outdoor sensors we use on our Vitotron 100s, 200s, and our current boiler product line as well on the gas side. So same resistance or thermistor 10K NTC. And should you want to use outdoor reset, always advisable, obviously reducing your number of elements coming on when it's during those shoulder seasons, going to save you a little bit of energy and a little bit of power. To utilize the outdoor reset function here, if you don't want to use it, you can also use what we call constant supply temperature. You can program in a fixed temperature. So it'll operate either or for your space heating system. And when you do that, you'll notice that on the actual display screen, there's a little red dot at the very bottom right-hand corner. When you're using outdoor reset, that little dot is illuminated. When it isn't, you're in fixed set point as far as your operation. And there's the heating curve that we're looking at. So you just very similar to what we have in our current Vitotron's line and Vitocross line of gas-fired boilers. They just use, instead of the actual curve itself, they number them 1 to 9. And then we have a shift or offset, so we can do a parallel adjustment of the heating curve as well. So just some customization capabilities on these heating curves that you can install and put into these little units. And of course, like I say, if the outdoor sensor is not installed, you're going to operate off a fixed set point. You just won't have any contacts on that little outdoor sensor there. If you put the outdoor sensor on there, it automatically will switch to a heating curve for your use. So let's have a look at a few of our applications, as I mentioned. So those are all the neat little components that are built into this little boiler that you won't have to pick up off that wholesaler when you're installing it. So all that stuff is kind of in that tight little package that you see on the slide there inside that boiler. But if I'm wiring up, say here's a good example of no primary secondary using the boiler pump inside of the unit. We just have essentially whenever that pump comes on, it always has the same flow, always has the same pressure drop through that little heating coil in that air handler. The thermostat goes to the air handler. The air handler is going to give us a TT call, a dry contact. That's going to go to the TT on our unit there. Should we be using the time of use or the off peak, we have the ability to wire that in as well. But effectively, this is very simple wiring, all dry contacts here from your heat source to the emitter to back to the boiler off of the TT. And now, based on other outdoor air temperature here, we got the sensor connected. We have a heating curve. It would fire based on whatever the temperature was that day and the heating curve that you have selected. So we see direct connections, return on the right-hand side, supply out. And of course, we got the air vent inside of the boiler. We got another little air scoop connected here, but some pretty simple little wiring. And of course, we put the little purge tees in here. Always a good idea to have some purge tees, just to makes it easier for you to get the air out of that system. So as far as service goes, always good to have that. Startups obviously makes your job a lot easier if you got some purge tees in there to set that. The only thing you have to set here now is what speed setting optimizes your operation of your heat pump, or actually your heat pump. I got heat pump on the brain, Patrick. What optimizes your heat emitter here? So as far as what pump speed I've got here, it's going to be a real good function of the pressure drop through this coil and the piping and which one we're going to set. And the nice thing is, of course, the unit itself will tell you what its flow rates are as you set that pump speed from 1 to 3, and you can kind of dial it into a nice setting there using the diagnostic tools on the boiler itself. Getting into a little bit more of a typical hydronic system, low temperature, using radiant inflow as an example here. You got some telestats, just simple 24-volt wiring in the thermostat that controls the zone here to those telestats. Then the end switches from our manifold, from our little heads there, go up via dry contact, at same spot that the air handler contact would have gone on the dry potential free. Close that contact, and now we've got a secondary pump. Both those pumps will be enabled, and of course the boiler is going to energize the number of coils it needs based on the outdoor temperature. In this case, again, we have the outdoor sensor, and of course where our heating curve is sitting and kind of what desired temperature we're going to be looking at that day as far as our requirements. Once the system is satisfied and opens up, what will happen is there is a delay, fixed delay of about 3 minutes on these little pumps before they'll shut off, and after the call for heat is satisfied on that side. All right. So some other ones, if you're doing two temperature system here, so we got multiple, or not just in two temperature, but two different type of heat emitters. It might be around the same temperature. It could be a staple up radiant system here, for instance, and some panel rads, low temp panel rads here. So we're designing for the same temperature. No mixing valves required on the system here. If we did need, if we're doing two temperatures here, the good point to remember is that we only have one set point on the boiler. So it's not going to give us multiple temperatures as far as our call for heat here. If I had a radiant system here that required a lower supply temperature versus the panel rad, I'd put a thermostatic mixing valve in place here to make sure that I didn't overheat that radiant system. But in this application, we're accepting the same temperatures on both of these styles of emitters. Thermostats wired to their zones as typical to the 24-volt side. One common call. So all of our zone valve here, our telestats are all wired back to the main end switch contact on the boiler control. Of course, regardless of what emitter here is calling, boiler is going to accept that set point and fire to that to whatever we're looking for there. And just a note, when you're piping like this with zones instead of pumps, you may need to have some sort of flow setters, right, to balance the flow rates that were required on the system. We can't use the little the bypass for that. It's not really meant for that type of application. You'd want to set your circuits here at the individual emitters that we're looking for, so we get the right flow rates for each one of these. All right, and again, that pump head, because we're only using this single pump, you got to consider what the longest run here as far as pressure drop is. Make sure we set that little bypass, differential pressure bypass inside of the boiler. Once we have all these zones open and we're kind of cooking through there, and we get that, make sure that pump stays on the kind of the knee of its curve. And different but the same, we have zone pumps here instead in this application. And what we're looking at here is using some sort of a zone box, some type for the pump modules. We're not going to use that secondary pump output inside of the boiler because we have two separate pumps here. We only want these pumps to operate whenever their specific thermostats are calling. And of course, you don't have to have balancing valves in this application. We were going to essentially allow the pumps to operate based on their pressure drops for their individual emitters here. Same thing, just a dry contact off of our little zone box back to our boiler. Boiler gets the call for heat, and whatever that set point is for that particular time of day and with the temperatures outside, that boiler is going to fire to that and stage based on what we're looking for. Kind of showing a couple of options for the expansion tank in these as well. So the little blue expansion tank down here on the bottom. Nice spot is usually off of that supply side here, off of any little residual air vents that you might have. Good spot for that little second expansion tank, should you need one to be installed. And of course, if we have a little bit more load than what we're looking for, maybe you need multiple. As I mentioned, in some applications, we're actually seeing guys install the boilers at the manifold locations for their different loads. So they're wiring their connections in separate areas. So the boilers are in completely separate areas of the buildings. But if you have a central plant here and one boiler is not enough, it is possible, obviously, to add boilers, and we call cascading. Now, these boilers don't have as some would expect with Viessmann that you'd have a cascade control for the boiler itself. With these little Vitotrons, we don't make an actual cascade control. Instead, you'd use a third-party control. In the West Coast here, Techmar is a fairly popular control to use in that application. But there are a number of other, staging boiler controls that are available out there. And essentially, we're just doing an enable-disable contact on these. So it's essentially just a straight TT. We're not doing 0 to 10 or any type of 420 milliamp. We're going to be essentially just stage these based on a dry TT contact from the control back to the individual boilers that we're looking at. So you're really only limited to the capacity of your incoming power as to how many of these electric boilers you can cascade into a system here, and of course the limits of the control you're using. But this would be typical system operation off of third-party control, and your boiler enable disable off third-party control. And the boilers are essentially just going to operate their staging of their own individual elements based on their own individual logic. So the actual cascade control that doesn't look after the individual staging inside of the boiler elements themselves. That's all looked after by the boiler. And of course, it's differential temperature from supply and return. And as I mentioned, when we first started, we actually are seeing these being implemented sometimes as a backup to our heat pumps. So we have a Vitotron 100 air water heat pump. We've been going on about this for a number of months now, lots of webinars. So if you haven't taken one in, we've got, we're building up a really good library of presentations for these little air water heat pumps. But part of it might be, an issue would be as far as the size of these heat pumps, and depending on where your climate is, you might need to have some extra backup. And a nice little electric backup on these little boilers to give you that little extra bump should you need that. Like I say, if your building heat loss is a little bit higher than what the capacity of the heat pumps are, this allows us to cover off a large majority of the heating season with the COP of an air water heat pump. And then when we need that extra little bit for a couple weeks of the year, then of course the electric boiler will kick in and look after the load during those particular times of the year. So it's a nice little setup here. You can see this is kind of the full gamut of our little air to water heat pump, the outdoor unit, the indoor unit, the electric boiler kind of sitting beside it there. But we add a buffer tank in there. It can do domestic hot water. We have multiple temperature capabilities with the mixing valve function, stuff like that off of that little heat pump as well. So you can kind of really expand onto your system here. And this is all electric. So there's no gas-fired equipment in here whatsoever. Everything is from the heat pump to the backup boiler are all using electricity versus fossil fuels. All right. So just a quick thing to go through the, I know we're about 15 minutes. I want to just give me a couple of minutes just to run through this. I don't want to go through, like I say, just to give you some idea of what the unit's going to show you after you do the installation. You're going to get into your startup. But you can see the little green LED here when it lights up. And of course, the symbols and what they mean on the little screen here. So I use the little navigation button, the little right arrow key here. I can push that. I can scroll through all these little areas here and what they're going to tell me. So if I've got heating operation, of course, the little radiator here, if it's green, we got a call for heat. If it's off, then we don't have a call for heat at all. If it's grayed out. If it's red, we have a call for heat, but the boiler is not the set point yet, so it's heating up. The elements are on whenever that you see that in red. If the green LED here is on, that means the pump is on. So our status of our pump on or off, we see that here as well. The temperature will be displayed on the screen. When you see the little navigation, you push the little button here and you see this little green LED lit up by the temperature supply out. So this is coming out of the boiler. And of course, the other detail here is the supply in. So the arrow pointing into the unit itself, that green LED is lit. We're reading the return temperature. And of course, our call for heat status. So if we got a call for heat here, then of course this will be green to let us know that we've got that call for heat. Now, if we've got I think a call for heat and our OP is on, this status will give us a different type of symbol to let us know that we got the call, but right now we're being blocked because the OP terminal is open. Right. So we use these little navigation screens here. If I go to if I'm looking at my system, so there's my call for heat. So there's the if it blinks, the OP terminal is open. So it's telling me that, yeah, you got a call, but you're being blocked because you're waiting for electricity rates to change. So we're essentially open that contact. So it gives you a good idea that your heating disabled, even though you have a call. If there is some issue, so if you've got some lack of flow, maybe you got some glycol in your system or whatever, and we got a bit of a slug because it's a colder day. If that pump icon's blinking, of course, that's going to let you know that we got lack of flow right now. And it'll try. And of course, once that flow rate gets up to operation, say, for instance, we're trying to heat up a little bit of glycol or whatever, of course, it would stop blinking and go back to solid. But if you've got any issues, so you got maybe multiple zones there or something like that, and maybe you got a high pressure drop in one of those zones that we weren't accounting for, and of course, that one zone calls, you start seeing blinking on the pump. That could tell you that there's too much pressure drop in that particular zone. And of course, we can't meet our minimum flow rate. You get that little icon. So we're kind of showing primary, secondary on the left-hand side versus you might see more of that little blinking LED when you don't have primary, secondary, and you're using that one pump and it has to push through all these zones and the pressure drops associated with those. And of course, some other status indications as well on the LEDs here, telling you what's going on here. So down below here, whether the OP is closed, the TT's contact's closed, the pump operation, we got another little LED and here as well. And this is essentially the flow rate I was just talking about, the error there. It has to warm up a little bit. You might get that flashing little pump output, just to kind of let you know if that thing is flashing that you might be dealing with a slightly slower flow rate, and it's going to build up if we're heating up that glycol in that time. As I mentioned, space heating, red, we're heating up, the boiler's heating up right now. If it's green, we're essentially supplying that temperature water that we're looking for set point. If we want to make an adjustment to it, all we have to do is go to the essentially to that particular area of the unit. So go to this. Essentially hit this little button, hit your little arrow key until you're essentially highlighting the little radiator here. And I can essentially use the plus or up and down buttons here, and I can change that if I'm going to fix set points. So if I just wanted to change, I'm at 110, and I want to change it to 120, I just have to use the right arrow key until I actually am essentially highlighting this little symbol. And then once I see the temperature here in Fahrenheit, I can increase or decrease it. And then essentially, once I move on from there, it's just going to accept that new temperature that I'm looking for. So very simple to make your adjustments on the fly. If you're using the heating curve, it's a bit of a different setup. Again, if that little LED, that little dot right there is lit, When you look at your temperature, then we know we're in outdoor reset. We're not in fixed supply temperature. And there was a little extra step you'll have to do to make your adjustments to your heating curve. We'll look at in a second. And there's your supply in and your supply out. We just talked about a little bit earlier. And all of the other things, like I say, it's going to tell you what your flow rate is. You can see your pressure, PSI, your actual BTUs that you're burning right now as far as consumption. So this is in real time, like how many BTUs, how many elements are on essentially, and what we're consuming as far as BTUs an hour. We can see that in real time. And of course, your outdoor temperature in Fahrenheit as well is sitting in that area. So if I wanted to change essentially the system here in the summertime from possibly turning on, and I want to keep it off, rather than just shutting the system off, we recommend just holding that little standby button for 3 seconds. It puts it in a standby mode, and the benefit of that is that it's going to activate your pumps. So it's going to keep those pumps kind of exercising throughout the summer, so we don't have those little pumps seizing up. And typically, like I say, that will happen every 24 hours. Essentially, the exact time that you put it into standby. So if I was to do that right now, it's like 10:51 right now in Langley, and I put our boiler into standby at 10:51 every day for while I'm in standby. It's going to put this pump into 15 minutes of pump exercise. So we're going to exercise that pump so we don't have it seize up when we want it during the heating season. All right. And then if I want to go into some more advanced settings, I want to hold this little standby button for 3 seconds. It puts it into standby. A little red light will flash on the screen when I'm in standby. Then I'm going to hold the arrow key here, the right arrow key, push it down, and then just tap the standby button again. And from there, I can go into a bunch of different areas. And the most one I want to talk about right now really is setting up your heating curve. So if I go to parameter 6 here, heating curve, I can make my adjustments of my slope or my shift in this area. So if I'm doing outdoor reset, the extra step is I've got to go into this advanced programming, these advanced settings, hold that little arrow key down, push the standby button, and then go to our parameter 6 here, and I can make those adjustments of my slope and my shift on my system here. So I can't really tell you where those numbers are going to be. It's all based on your heating system, what your requirements are, but you get some ideas of your max temperatures here that we're looking at, of course, what your deal is. So again, this is all in Fahrenheit. We're down to 0 degree Fahrenheit here on our scale, and of course, riding up maximum temperatures 140 Fahrenheit on that system. And of course, there's our shift and now our slope. And again, some guys will change their shift and slopes automatically. I tend to use the shift or offset more as after a year or so of operation, if everything's running well, I can start making incremental adjustments using the shift to kind of drop the temperature down a couple degrees. So the homeowner doesn't really notice it, but you're going to save a little bit of power because we're going to be using that much less juice during the heating season because we lower that supply temperature a little bit on that side. All right, so we go from +9 to essentially -9 Fahrenheit as a scale there. And if you forget anything, so as I say, we just went through a brief little presentation here. And if there's, you're going to install one of these boilers and, Scott said something about this or how to get into this menu. Again, the Academy instructors here have been really busy putting together a lot of these videos and presentations that are archived on our YouTube channel. So if you go to Viessmann Climate Solutions on YouTube, and I usually put this into playlist, and of course there's a list here of all of the Vitotron videos that are available there. Some of these are only a couple minutes long. Some of them are more marketing, but I know there's a number of ones here that are really good, quick videos to explain all of that stuff, how to get into the advanced settings, navigating through the user interface, all those things that you're probably going to want to have a little bit of a refresher when you're standing in front of it. This certainly won't be enough if it's 6 months down the road you're installing one of these boilers. But here's a really good resource for you guys to kind of utilize should you need to get some reference or some help there. So this stuff is available 24 hours a day, 7 days a week, as long as the internet is up, as long as you have access to that information. All right. So that's the presentation. How are the questions?
You knocked it out of the park. We did get one question. It was actually really good. It took me a second to think about it. One of the questions is why we decided to have a hinged door over a removable door like we would have on our Vitodens models, and a
Hmm.
lot of other boilers too as well. Um, and I got thinking about it. Now, one, my response to it, and I might be missing a point here. I know it's already an existing product in other markets and countries, so we didn't do a redesign for just this market.
Correct.
Electrical redesign, make sure we pass UL and a different voltage source for that control. Other things do come into play with those things, but the overall package was already an existing product across most markets in the world. So we just kind of North Americanized the electric side of it
Yes.
and send it out into the wild.
Mhm.
Not to say that that comment won't make its way back to the product management team and maybe a rolling change or an update occurs down the road. But even the largest unit, that 14.4 kW, gosh, what's that thing weigh? I mean, it feels like you're carrying a briefcase.
Yeah,
They,
it's
they,
there's not
they're
much to it.
they weigh about nothing. So you can grab a hold of the whole box and just mount it on the wall. One person. It really is pretty easy to do. And then even with the door open at just a 90-degree angle, if you had that kind of in a corner, if you get that door open to a 90-degree angle, there is more than enough room to do any service or anything you really need to
Absolutely.
do in there. Um,
I could check too if we could just remove it. If it pops off the hinges. I'm not sure if it does or not, but it's a
I
possibility.
I was
I
looking
don't
for
know.
pictures to see if there was like a quick release on the hinge too, and I couldn't see any photos. I know Mark's out in the field, so if he's got anything, just throw a Q&A.
Yeah.
But yes, I can't remember if there was a quick release on those hinges or not, as well. So possibility on that, but definitely worth mentioning and something we'll
Yeah.
send up the line to the product management team. Um,
That's why we do these, right? You get these good questions.
And Mark, so another instructor is just kind of in the class as well, lurking in the background. He also doesn't remember or know if there's any quick release on those hinges, maybe pull it out. I don't think there's a pin you can drive out. I think you'd have to remove some screws to do so. But as long as you had access to the hinge, you should be able to remove that screw off of the door if that
Yeah.
became a necessity. But again, playing with it, tearing them apart, putting them back together. I don't think that's going to be a. He's saying it might be riveted, so okay, might not be able to take that door off.
Yeah, that
It's
definitely
been
wouldn't be able to do
so
that.
if it is riveted, then yeah, that would be a little difficult. It'd be drilling those out and replacing it with a bolt and a nut and bolt.
That's a bit more than what you want to do
Little bit
to do
more than
that.
anybody wants to
Yeah.
do out in the field. So,
Yeah. Yeah.
and now that the same person asked the question says it's riveted, that is pinging memory that that door is riveted on there. Those hinges are. So
Okay. Thank you, sir, for that
yeah.
update.
But yeah, we'll send that back up and see. I could see we do. I've had the pleasure to install one so far at a friend's house, and it is in the closet. There's not a lot of room to work on it in there, but with
Yeah.
that door just coming out 90 degrees, I feel as though there's plenty on it.
Mhm.
But we'll run that up. Doesn't hurt.
Yeah, absolutely. Yeah. No, like I said, I could see where we got to swing that door out. It might be, but it's a pretty tight little unit on that side. But certainly would be occasions where you might want to open up a bit longer or wider. Nice thing is, like I said, there's no stuff to pull out for service necessarily, right? I mean, you're looking at the strainer in the bottom, a few other things there for maintenance that we're going to have to look at, but we're not trying to pull a burner out and do a full on maintenance of this thing. So there's some areas there where we may not have to have so much clearance to stand
And
in front of it.
we also got another comment from the same questionnaire. He's located near you, Scott. So he's talking to his rep at Langley and also the CIP Hex show up there as well. So
Okay.
it's been mentioned to some other people, but I'll make sure it gets mentioned yet again. Never
Yeah,
hurts to keep doing that. But thank you for alerting us that you've already kind of mentioned it to some people. But we'll multi-prong attack. We'll go on that one.
absolutely. Yeah.
Make sure it did get heard and didn't get lost in translation anywhere. There's a lot of info
Mhm.
that comes in, especially at those shows. So
Absolutely. But good point. Thanks for that.
Yeah. But yeah, as far as, I mean, it's not a combustion product, so we're not getting in there and really, you don't have to scrub the heat exchanger. Really looking at just water quality, maybe a flush every so often after you take a look at that magnetic Y strainer, see if it's going to require maybe a flush of some sorts, an inhibitor being put in there, some
Hmm.
Sentinel or Fernox, or maybe it's already glycol. That's a natural inhibitor. Make sure you keep up on the pH there. We don't want to ruin any gaskets, but
Yeah,
um,
absolutely. No, like I say, I've had the same experience. I've installed one, like I say, in our facility here, but I've done some troubleshooting in the field on these things as well, and we'll put together a presentation down the road here, kind of continue on with some other aspects of this boiler. But troubleshooting is really simple on these things. It's just like I say, just with all the other details in there of your pressure sensors and your temperatures and all the other things, and the test ports are nice and big, so you can, as far as troubleshooting this thing, it's really quite easy to navigate around. So it's I was impressed. Um, the first time I had to do some troubleshooting on one, it was pretty quick and easy to figure it out.
yeah, you don't even need the needle leads on your multimeter anymore. Just those standard leads that come on every
Hmm.
cheapo multimeter that are bulbous and you can't get into other places will work on this thing with no issues.
Yeah, yeah.
I did mention, see, this is why having the banter back and forth. So me mentioning glycol in the system sparks the question, can we run glycol through the system? Yes, you can put glycol in the system. We always recommend never more than 50%.
Mhm.
You should only put as much glycol in the system that's absolutely necessary, as well as maintaining the pH levels on that glycol yearly. The glycol does need to get replaced depending on
Absolutely.
how much, the way the system operates, the temperature of it, all sorts of different variables go into that. But glycol does need to be replaced
Hmm.
every so often. In my experience, I haven't seen glycol last more than 5 years without a replacement. Some quicker, I've seen them stretched a little bit longer, but
Yeah,
not usually ideal as they tend to go a little more acidic and wreak
absolutely.
havoc on those gaskets and fittings.
Yeah, and it can be pretty severe. So, like I say, most of the time it's well, everybody's a little bit different, but like I say, a lot of places now will sell you a 50-50 mixture, like it's pre-mixed, and I find those are it's distilled water that they're using from the manufacturer, and so you know what you're getting is the proper ingredients, right? You're not using tap water from the source and then trying to blend in a 50-50 mixture with your pure glycol.
And
Makes a
you
big
don't want to
difference.
mix glycols together because they do have different chemical makeups and properties, and topping off with this glycol, and you don't know if it has some other glycol in it. Be very cognizant of that you're using the right glycol. I've always been a proponent of writing on your glycol feeder, exact make and model, just
Right on.
Sharpie right on that Axiom feeder. So the
Good
next
point.
technician, if it doesn't happen to be me, knows that that's what was in the system, and maybe they just top it off with the same stuff, or maybe out of habit they get it all out of there and replenish it with new. And that's not something we need, as Scott mentioned, if you buy the 50-50, you put everything in with that 50-50, you have a distilled water, the glycol mixture on one side. We're not too concerned with that poor water quality and that exchange of that water all the time. Whereas if you were using tap water, now we need to treat the tap water before we add the glycol to make sure we are putting that right water quality in the system, especially with electric elements. Think of it
Mhm.
like electric water heaters. We all know that calcium and things can get burned right on that element. Um, and this is going to get a
Absolutely.
little bit hotter, a little more concentrated in a smaller vat of water, so that can actually be exacerbated a little bit easier with a little more usage than you would see with your typical DHW electric tank.
100%.
Have a great week, whatever it is for you guys. So
All
we'll
right.
see you next
Take
time.
care. Bye bye.
Bye.